attempt to do a differentiation from first principles revision. First of all, everything about differentiation is about gradients. That's the key information here. So what we want to be able to do is first of all find the gradient of a chord, by which I mean the line between 2 points and the gradient of that. So we're going to take the change in y, the height, divided by the change in x. So we're and that gives rise to this formula, but we're going to come back to that in a moment. First of all, let's just see what this is going, what's happening visually. The questions are always not visual, but really everything is visual. So here, if I want to take this black curve and find the gradient of this red tangent at the point P, then I can take another point Q on the curve and draw this dotted blue chord between them. And here, the difference here, they call it Pn, in our case we're going to call it delta x, is 1.77. If we make that number get smaller and smaller and smaller and smaller, look what happens to that blue dotted line. It's getting closer and closer to the red tangent. And when that difference delta x becomes 0, the gradient of the tangent is the same as the gradient of that chord. I mean, the chord doesn't quite exist because it needs to have some sort of length. But we can say that as it gets smaller and smaller, approaches 0, it gets closer and closer to the gradient of the tangent. And that's the principle behind what we are going to do. So that gives rise to this equation here. The gradient of the chord is the change in y divided by the change in x, and that's what this formula is. I'll have a look at it in a moment. But I'm not going to use this formula as a formula. I'm going to explain it in terms of the picture. So first example, from first principles, find the differential of y equals x squared minus 5. So let's start by drawing a sketch. Okay, it's going to look something like this. Okay, and I don't mind what point we're differentiating. We're going to find an equation that tells us the gradient of every point on the curve. So I'm just going to take 2 points. Okay, I'm going to call that one x. And this one here, we're going to call, that'll be the point x plus a little bit, which we call h. And that's the chord that we're going to look at. I'm sorry, it's a bit small. And there's our triangle that we're going to find. Brilliant. So we're going to put in the y value here. That will be just x squared minus 5. And here, the height of that point is going to be x plus h squared minus 5. Okay. So to find the gradient of that chord, we can write gradient of chord equals delta y delta, which is going to be the difference in our two y values gives us x plus h squared minus 5, subtract x squared minus 5. As you can see, that's probably going to cancel somewhat. Divided by change in x. Well, the change in x, we could say is x plus h subtract x, but that's just going to be h. That length there is just h. So we'll say h. So all we're going to do now is simplify this big little expression. We're going to get x squared plus 2xh plus h squared minus 5. We're subtracting x squared. And we're going to then subtract a negative, which is then adding 4 divided by h. Here we can then see that, and the 5s are going to cancel, and the x squared are going to cancel. We're going to be left with 2xh plus h squared over h, which simplifies to 2x plus h. So now we want to do this process where we make the chord smaller and smaller and smaller. So here what we're going to do is we're going to make that h smaller and smaller and smaller and smaller until that chord gets closer and closer to the tangent. So we just say as h tends to 0, okay, that's the making it smaller. We can see then that delta y over delta x tends to, well, this thing here is going to become 0, or goes close to 0, we'll just be left with 2x. We can conclude, therefore, dy dx equals 2x. Another type of question that you get asked is specifically the gradient at a point. This is very similar, but it's a little bit easier because there's a little bit less algebra. Okay, so here again, let's draw a diagram. Y equals x to the 4. Just do it like that. We want to draw on our 2 points. Okay, this time instead of x, it's going to be 1 and 1. And here we're going to have, again, we're going to go along a little bit. So we'll have 1 plus h. And then this here will be 1 plus h to the power 4. That will be a height. So again, gradient of the chord, which is equal to delta x, is going to give us 1 plus h to the power 4 subtract 1 divided by h again. Hopefully now you're starting to see where this formula came from at the beginning. We've got here the difference in our y values divided by the difference. Okay. But it's a lot easier to remember than a big O formula. It's just the gradient of the chord. Let's expand that. Here we're going to have to use our binomial expansion. So here let's do 1 Pascal's triangle to help us do that quickly. All right, and then this is going to give us the coefficients when we expand this term here. So we're going to get h to the power 4 plus 4 lots of h cubed plus 6 lots of h squared plus 4 lots of h plus 1. We've also got to subtract 1. Divide everything by h. We're going to get, simplify that and then cancel. Divide everything by h to the 3 plus 4h squared plus 6h. So that's the gradient of the chord. We can't simplify that any further. So all we need to do is, sorry, not that, let's say as h tends to 0, as we make that triangle smaller and smaller and smaller, the chord will come closer and closer to the tangent. We can see that the y equals x is going to get closer and closer to, well, that becomes 0, that becomes 0, that becomes 0, and we just got with 4. So we can conclude the gradient of y equals x to the 4 at 1. Okay, so what I'd like you to do is have a go at these 2 questions. They're very similar to the 2 that I've done. Pause the video, and in a moment I'm going to share the answers. Okay. And now the answers. are as follows. Here's the answer to question 1. Pause the video, have a read of my solution, check that it's the same as yours. And here's the answer to question 2. Again, pause the video, check that it's the same as yours. I hope that's been helpful. Good luck.